So, hello guys, welcome to IGC. Welcome to IGC. Am I audible? Please respond in chat box. Please respond in chat box. Yes, so let's start our journey. Okay. So, guys, we are discussing from yesterday, GATE 2023 Aerospace Engineering Solution. Aerospace Engineering Solution. So, myself, Dinesh Kumar, and in this session, I'll be discussing aircraft structures part as well as mechanical vibration. So as far as aircraft structures part concerned, there are two questions as usual. One is for 1 mark and another is for 2 marks. So the total is 3 marks, okay, in GATE 2023. And both of the questions seems to be, simple, but in same time, bit different. Okay, so I tell the how the questions are different, and as well as how those two questions are simple. Now, question number 27 is from thin wall structure, and if you read this question, what it says: which of the following statement is or are true? Is or are true? True about the ribs of an airplane wing with semi-monocoque construction. So guys, earlier also there are questions from these components of thin-walled components of aerostructures and from rib as well. So this question is in line with the previous question, but one additional, point is asked. So when we read these options, we'll come to know. So what is the first option says? For a rectangular platform wing, the dimensions of the rib do not depends on their span-wise position in the wing. So tell Rajendra, is it correct or wrong? Tell Rajendra, is it correct or wrong? So we all know, guys, the rectangular wing platform is like this, okay? And suppose this is the root and this is tip, okay? So we all know throughout the wing, the cross section remain same, right? So this is what span wise direction. So your rib cross section will not depend on the position of position of rib, right? So what is, so tell me, Tangamotu, is it correct or wrong? So this option is correct. For a rectangular platform wing, the dimensions of the rib do not depend on their span-wise position in the wing. So this is the correct option. Now option B, rib. Ribs increases column buckling strength of longitudinal stiffeners connected to them. Yes, by redistributing stresses at discontinuity. So always rib increases buckling strength of longitudinal members like stringers or spar. Okay, so that was the previous year question. Okay, now read option C. Rib increases plate buckling strength buckling stress of the skin panel. This seems to be wrong. Why wrong? Because usually what see, this is the rectangular wing platform. So suppose one rib is here, another is here. So what it is doing is it is dividing our skin panel in multiple small plates. So that means this will increase the buckling strength. So that means your rib like the buckling stresses will go down. Okay, buckling stresses will go down. So C is not the correct answer. Now D, plate buckling stress. Let's see, read this option other way around. Just a moment. Rib increase, plate buckling stress of the skin panel. Skin panels. So buckling stress means it's allowable or applied. So here bit of confusion for me. Rib increases plate buckling stress. So it's allowable or applied. It's allowable or applied. Plate buckling stress of the skin panel. Any because it's a language. Anything you want to suggest, guys, on this? See, basically what it is saying, it is increasing buckling stress. That means it is increasing critical stress. So indirectly your critical load is high. That means your allowable is high. So I believe C is also correct answer. C is also correct answer. Okay, C is also correct answer. Okay, so it's your allowable critical stress will increase. Okay, and rib of course maintains aerodynamic shape of the wing. So your correct options are A, B, C, and D. Okay. Now, when C cannot be the answer, if they write ribs decreases, okay, something like that. Okay, because the buckling will happen due to the applied loads and applied load and along with external disturbance. So ribs actually increases critical buckling stress. Okay, it increases critical buckling stress. So A, B, C, and D, all four are correct. Yes, yes, Tangamotu. Anyone else have any comment on this? Okay, any doubt? Okay, so let's move to next question. Yeah, so what this question says, the shear flow distribution in a single cell thin walled beam under the action of an arbitrary shear load SY applied at the shear center as shown in the figure. The cell has horizontal symmetry with booms marked by 1 to 4 that can carry direct stresses. The shear modulus G is the same for all the walls, and the area of the cell is 1,35,000 mm square. With respect to the point O marked in the figure, the distance to the shear center S is. So guys, if you see this question, they ask the shear center position from point O. Now guys, usually whenever we have done shear center problem from gate perspective, generally we do for open section. Okay. And in that case, for open section, we first find what? What first we do, Mr. Thangamatu? First we find shear flows. Okay. First we find shear flows. Okay. Because in closed section, finding shear flow takes a lot of time. Okay. But in the given question is what? The section is closed section. The section is closed. And guys, they also given the shear flows. Okay. You can see guys, the shear flows are given. So that means we know the what is the shear center, guys? We know all the shear center for any section. Let's see, suppose this channel section, and for channel section, suppose I am considering my shear center is here and this shear force SF is applied. Now, if you want to find the shear center position from this web, we consider this is the distance, okay, some distance E. So what we do, what is our procedure? We do moment equivalence. We do moment equivalence when we find the shear center position. So we write what? Sy into E. Suppose we are doing about this point. So what we do? Whatever shear flow suppose flowing in this 1 to 2. So this moment equivalence means what? This shear force above this point is going in what? Clockwise direction, and this shear flow about this point will be equal, because this will also go in clockwise direction. So suppose here my shear flow is what? Q1 to 2. So usually what we do, Q1 to 2 into ds, then we multiply with this distance y, and then we integrate 1 to 2, right? This is what we do in moment equivalence. So same thing here we have to do, guys. If you look at the question, it's very straightforward question. What I will do, due to Sy, I will do moment equivalence about point O. And another good thing, this section is symmetric. They have mentioned it is symmetric. Now there are some additional information like this area is given. Basically, it is not required. Okay, it is not required, guys. You can solve without this area, without G value. How? When I do moment equivalence about point O, so that means what? This Sy into Os is what? Moment. And guys, this is in what direction? Clockwise or anti-clockwise? It is anti-clockwise. It is anti-clockwise. So I have to equate anti-clockwise moment equal to anti-clockwise moment, because I am doing moment equivalence. Now guys, first I will take 4 to 3. The shear flow is going in this direction, and about this point O, this will give me in anti-clockwise only moment. So that means this is 0.61 into 10 to the power minus 3 Sy. What is the length? It is 500. And what will be the momentum? This will be the momentum. It is 100. Now guys, this 3 to 2 is again going up. And if you take moment equivalent, moment about this point O, it will give again anti-clockwise. So that means it will be added. So it is 2.86 into 10 to the power minus 3 Sy. And then again, the length is how much? 200, and momentum is 500 here. Okay, the momentum is 500. Now guys, this 2 to 1. So 2 to 1 is going in this direction. Okay, it is going in this direction. Now this shear flow into length, and about this point when you do moment, it will give again anti-clockwise. Okay, So it will be added here. So it is 0.61 into 10 to the power minus 3 SY into 500 into moment arm is 100. Now guys, this which is 4 to 1, it is going in this direction. So about point O, how you will find moment. So guys, for this, suppose if I take a small section, okay, length ds. So my shear flow into C, and this is R. So guys, this ds will be nothing but R d theta. Okay, R d theta. And we know what will be my force. Force will be the shear flow into ds. That means this shear flow is 2.14 into 10 to the power minus 3 sy into r d theta. Now guys, this is force. So what is the momentum about point O? It is r, and it is from what 4 to 1 means it is 0 to pi. So guys, right here. So what it will be 0 to pi 2.14 into 10 to the power minus 3 sy. Then it will become r square d theta. Now, when we solve and simplify, what we will get? Sy will get cancelled throughout, so you'll get Os will be equal to what? 2 into 0.61 into 10 to the power minus 3 into 500 into 100 plus 2.86 into 10 to the power minus 3 into 200 into 100 and plus this term. Okay, so that term means what? It is plus 2.14 into 10 to the power minus 3, and r square I can take out. What is the r value? 100 square and integration of theta. So see, if you integrate 0 to pi d theta, it will be what? Pi. Okay. Now, this OS, if you solve this complete equation, you will get around 80 mm. We will get 280 mm. So guys, this question maybe looks tough, but it is a very simple question just based on moment, equivalence, and all the values are given, we can do. And someone asked how the radius is 100. You guys can see this is 200. So this will be the diameter of this semicircle. If you take circle, so it is. Now, guys, one question we have to do. One thing we have to do, guys. Okay, which I have not done very far. Can you guys find the total area, which is like 500 into 200 plus pi r square by 2? Okay. Can anyone calculate this? This check. Can anyone do this? This area should be equal to this given value. Yes, guys. Hello. So, anyone, if you check this area, that means if you take this as a area and you calculate, for me it is coming as 115,708. Okay, so that means what we have to do, guys, in this case, uh, it will be like this. If you take a small section of length ds, so this ds into this row will be what the moment, and then multiply and divide. Okay, so that we have to do. So it will be dA. So that means d into row dA, then it will be simply 2.14 to 10 to the power minus 3 SY. And then now A. So what will be the area A? Area A will be when it is integrated from 4 to 1, this will be area ds, so multiply and divide by 2. So it will be 2 here, and then in the area, so it will be into 2. So, so the area will be 135,000 minus um, it is so it is 500 into 100. No, 500 into 200. So let me check. 500 into 100. So that means it will be minus 2 into, so 2 into 135 triple zero minus 500 into 200. Yeah. I think, guys, the answer may vary here. Answer may vary. It should be, the answer should be not 280. It should be 197. I will explain why it is 197. Okay, 197.2. The reason, guys, it looks semicircle, but actually it is not semicircle. If it is a semicircle, we can find the area after this total, which will be 500 into 200 plus pi r square by 2. So if you do this, it is what is 500 into 200, then plus pi by 2. Then r is how much? 100 is square. So by that, area comes only 115708. But the actual area is given as how much? 135,000, guys. So this is like, if we take semicircle, it comes this, but actual area, this is the actual, is not correct. So that means we have to change bit of our approach here. So what will be the way? It is same. The procedure is same, but the only thing what it will be like OS into SY, which is anti-clockwise. Now guys, this will be equal to, I can write now directly 2 into 0.61 into 10 into, just a moment guys, into 10 to the power minus 3 SY into 500 into 100 plus it is 2.86 into 10 to the power minus 3 SY into 200 into 500. Okay, then plus. Now the question comes, guys. Now the question comes. Okay. Now, guys, semicircular, not semicircular, for this curved part. So for curved part, how we will find? So guys, when we consider this small ds, okay, which is at some distance, suppose rho, okay. So guys, this ds, you can see this is making a triangle. So this ds into rho, and this is shear flow, right? So this ds into rho, if you multiply and divide by 2, multiply and divide by 2, let me check when I did. I multiplied. So when you multiply and divide by 2, what will happen? You can see, here, this will be small area dA integration 2 into shear flow. Now shear flow is constant. I can take 2 out. So it will be 2 into shear flow, and integration dA is nothing but, now guys, how we will find the area of curve? So it will be like 2 into shear flow. So what is the shear flow, guys? It is 2.14 into 10 to the power minus 3 SY. Now area, it is multiplied by area. Area will be 1,500 minus 500 into 200. Okay. Now if you solve this completely, you will get OS, SY will get cancelled, and you will get OS equal to 97.2 mm. Okay. So guys, anyone has any doubt in this question? I think it's a very good question. Here they listed in terms of this shape. So please guys, don't consider it as a, this curved shape as a semicircle. Okay. So for that, we have to use this circle. What we find force. So my force df. Df is always what? The shear flow into ds. You guys will be knowing in Bradbury theory. We do that derivation. So df is what? Your shear flow into ds. Okay, and then we find moment dt, right? So dt is what? Df into rho. Then we multiply and divide by 2. So that approach we have to use, and the answer will be coming for this question. Answer is coming as 197.2. Guys, if you guys can do calculation, tell me. Yes, Tangamoto. Are you there? Anybody can do this calculation? So, guys, in exam, uh, it needs to get. When I did first time, I also didn't cross check these areas. Anyone have any comment? Any comment, guys? it was a 2-mark question. It was easy question, but we need to take care of few things while solving this question. Any question? There are only two questions from thin walled structure. So for the first question, all 4 options are correct, and for this 197 point answer. Yes, those who are watching on YouTube, tell me guys if any doubt, any concern. Okay. Now let's know. Sangamutu, are you there? Okay. So guys, that's involved structure. Now mechanical vibration. So guys, mechanical vibration was also quite simple in this gate paper. Okay, so they asked there are 2 questions as usual for 1 marks and another 2 questions for 2 marks. Okay, for 2 marks there was 1 question. So the total is, so 2 plus 2 it is like 1 into 2 and 2 into 1. Okay, it is like that. Now guys, read the first question what it says. It is MSQ. This question number 25 is MSQ. And if you read this question, I think some of you or most of you can answer this question. Read the question what it says. Which of the following statements is or are true about harmonically excited force vibration of single degree of freedom linear spring mass damper system? So guys, it is like that. There is a spring mass system with damper, and it is excited with some force, harmonic force. Like let's take F naught sine omega t. So it's a case of harmonic force vibration. Now for harmonic force vibration, the solution is given by what? Complementary function plus particular integral. Now complementary function is like from your damped free vibration. Damped free vibration. And particular integral gives me steady state solution. So this is what this the solution from free damped part is known as transient response, and the solution from particular integral is known as steady state response. Now this the steady state response doesn't depends on initial initial conditions. It doesn't depend on initial condition, but your A2, your free damped vibration solution will depends on initial condition. And also guys, here whatever the solution I have given, it is for under damped. Okay, it is for under damped vibration under force excitation. Now guys, now look to options. What it says, the total response of the mass is a combination of free vibration, transient and steady state response. Yes, that is already I have shown you guys. That's correct. Now, the free vibration transient dies out with time for each of the 3 possible conditions of damping: under damped, critically damped, and over damped. So guys, we know for under damped vibration, theoretically it takes infinite time. Theoretically, system never comes to theoretically system never comes to rest. So that means this statement is wrong. Never comes to rest. Okay. And in critically damped system, the system will take least time to come to rest. And if the system is over damped, so more the damping, more will be sluggish motion. So B is not true for all the conditions. It's true for critically damped and also for our dam it will be okay, but it will take more time. So B is not correct. Read the C option. The steady state periodic response is dependent on initial condition, which is wrong. Only your transient response depends on initial condition, which is what at time t equal to 0, what is your displacement and velocity. So C is not wrong, not correct. Now read D. The rate of decay of free vibration transient response depends on the mass, spring stiffness, and damping coefficient. So, guys, rate of decay usually come in picture for what? Under damped vibration. So, rate of decay comes for under damped vibration, and we know rate of decay delta is almost equal to 2 pi zeta. Now, what is the zeta, guys? Zeta is C by Cc. Now, what is the Cc? It is 2 pi C upon 2 under root Km. So that means the logarithmic decay or decay depends on what? C value, K value, M value. So what it is given? It is given mass, spring stiffness, and damping constant. So D is correct. So what is the final answer for this question, which is MCQ? A and D is correct. A and D is correct. So guys, any doubt, any concern on this? A and D is correct. Any doubt? Any concern? So guys, it was a good and a simple question. If you know concepts well, you can answer this question. With the link. And in IGC mock exams, we have kept many such MSQs from vibration. Okay, so you guys can refer, and everything is given in IGC notes as well. Whatever these pictures I have taken, these are from IGC notes. Guys, these pictures which I have taken, Thangamutu, if you are there, you can tell, right? So, if you go through my notes, it will be kind of more than sufficient part. So, these, okay, let's move to next question. Yeah, so what it says, for studying wing vibration, a wing of mass m and finite dimension has been idealized by assuming it to be supported using a linear spring of equivalent stiffness K and a torsional stiffness of equivalent stiffness K theta as shown in the figure. The center of gravity CG of the wing idealized as an aerofoil is marked in the figure. The number of degree of freedom for this idealized wing vibration model is. So guys, basically, if you see this and CG is here, so how it can vibrate? Like, what is the degrees of freedom? The number of independent coordinate required to define motion. Now, guys, this, if you see, this can vibrate in this direction. Translational direction means this can go up and down, right? So suppose that displacement is what? X. Now what happened? This wing aerofoil or wing can also, vibrate about this point, okay, in this rotational vibration, right? So suppose this theta. Now guys, if you find the final displacement of this CG, what it will be? It will be X plus, suppose this length, okay, it will, so it will be like this length. So suppose this distance is known, CG distance. Okay, so what it will be like theta into that distance, like some distance is CG. So you need two different coordinate to define the complete motion of this aerofoil. Okay, so or wing section. So what x is translational and theta is rotational. So the degrees of freedom here are 2. Now such questions are there, okay, in Grover. Grover is there, in SS Rao is there. But here they just ask degrees of freedom. They didn't ask final solution. But in if you go in such those standard textbook, even they ask to find modes and all for such questions. So 2 is the answer, guys. Okay. Now, guys, move to last question from vibration, and it was a very simple question, a repetitive question. What it says: a single degree of freedom spring mass damper system has viscous damping ratio 0.1. The mass is given an initial displacement of 10 centimeter without imparting any velocity. So that means at t equal to 0, velocity is 0, and x equal to x naught, which is given how much? 10. Now, guys, what they told? After exactly two complete cycles, exactly two complete cycle of oscillation, where TD is time, the TD is what? Period of damped vibration. They ask the amplitude of the displacement is after two completion of the cycle. So the number of cycles here they told two. So for two cycles, how many amplitude you require? You require three amplitude. The total will be how much? Three amplitude. So that means you will have x naught, x1 and x2. So what is asked? At the completion of two cycles, the amplitude. So x2 is unknown. Now we know what is delta, guys. Delta is what? 1 by n ln of x naught by xn. So it is 1 by 2 ln of x naught by x2. And we know what is the delta? It is approximately 2 by zeta. So guys, from here, if you find x naught by x2, it will be e power 4 by 4 pi zeta. And in this question, x2 is asked, so which is what? X naught upon e power 4 pi and zeta. Now substitute everything here, so it is 10 upon e power 0.4 pi, because zeta is given as how much? 0.1. So from here, if you find what will be the your x2 value, guys, what will be the x2 value? If you solve, it is 10 upon, so I'll get my x2 value as 2.84. Let me check the answer. Question number 51. So 51. So it is 2.84 centimeter. Okay. Now, guys, if you see the how I decided this amplitude, that also we can see. So they are telling two complete cycles, right? So you guys can see. So that is suppose x naught. So this will be two successive amplitude, right? So this will be x1, and then this will be x2. So this is one cycle, and this is complete one cycle. Okay. So guys, that's all from vibration question. So there were only three vibration question and two questions from thin word. And if you guys have any doubt, any concern, you guys can ask. Okay, I'll be happy to take up. Yes, guys. Any question, any doubt? Okay, those so guys done from my side. So thank you all for watching this session. And ITC is starting uh, GATE 2024 classes, 2024 classes from Feb 19, and our classes are live interactive classes. live interactive classes. So you can ask n number of questions during classes. Okay, it is kind of offline classes. And after live interactive classes, you will get recording of live class also, recording of live class. And guys, we are not selling our online course, course in name of live and just providing recording. Our classes are purely live interactive classes. And second thing, guys, we are a team-based institute. So you can see our teamwork. We are the very first institute in India to provide the solutions video on YouTube. And by 10:30 a.m., we will release our answer key also. Okay, we are ready with key in night itself. Just we are rechecking. So by 10:30 a.m., you will get the answer key for the whole uh, whole paper. Answer key for whole paper. This will be shared on IGC website, and we will provide the link. So at 9:30 we'll be studying another session for propulsion. So guys, if anyone have any doubt, can reach and do watch the propulsion session. Okay. Now guys, apart from this live interactive online coaching, we have programs like Target Gate course, which is recorded course. So those who want to learn on their own time, on own pace, they can go for Target Gate course. Okay, Target Gate course. Also, we have DLP programs, distance learning program also. You guys can visit our website. Okay. So I think what I take from this session, I feel the thing called shear center question was easy, but here we need to be careful about the specifically area part. Okay, you cannot just you assume semicircle and do calculation. Okay, in first chance I also did. Many of you might have done in GATE exam, and that will be a mistake. Okay, but actually we need to take area properly, and it's like you can say now it's a question combination of bread weather theory plus you know shear center finding approach in terms of the concept. So answer is 197.2 mm. So that's all from my side. Thank you guys. We'll meet again at 9:30 a.m. With another new session with Mr. Akshay sir, who is a propulsion expert at IGC. So I'm organizer, but I only take care of aerostructures part, and that too nowadays only thing called structure and vibration part. Rahul sir assists me, then Shyam is there. So in IGC we are team, even Sumit is there. So for every subjects we are multiple. If you take aerodynamics, we have Nitin sir, we have Naveen, Rao sir, we have now Dipnil also. If you take propulsion, we have Mr. Akshay, we have S. Kumar sir, we will have him this year, Nandani also in our team. If you take flight mechanics, we have multiple experts. Navneet sir is there, Nitin sir can take care of aircraft stability, Naveen sir take care of aircraft performance. If you take mathematics, we have four faculty for mathematics. We have Dheeraj sir, we have Ravin sir, we have Mithilesh sir, we have Prashant sir. So this is what the strength of IGC. If you take aptitude, we are the only institute those who are claiming earlier days. We only teach aptitude in India. But you guys can see we have the only institute who is providing complete PYQ solutions, complete PYQ solutions for aptitude that is on YouTube. Okay, you guys can see our live sessions prior, this prior gate 2023. So thank you guys. At 9:30, not PM, guys. 9:30 a.m. 9:30 a.m. 9:30 a.m. 9:30 a.m.